All right, so we just talked a little bit about our empirical rule and talked about what we know about different data values based on how many standard deviations we are away from the mean. Standard units measure a value relative to the sample rather than with respect to some absolute measure. A measurement converted to standard units is called a z-score, which measures how many standard deviations an observation is away from the mean. The sign of a z-score can tell us many things. The z-score of the mean is always 0. A positive z-score shows the observed data value is greater than the mean. A negative z-score shows the observed data value is less than the mean. So if we were to look at this image here, we've got a dot plot of the heights of 247 men marked with z-scores as well as heights in inches underneath. So a man who is 73 inches tall would have a z-score of, if we look at this 73, we see a z-score of 1 because we are 1 standard deviation above the mean. So we have a z-score of positive 1. A man who is 64 inches tall would have a z-score of negative 2 because we are 2 standard deviations below our mean. Right? Then we can also be asked other questions. How many men would have z-scores greater than 2? Well, we have 2 little dots right here. Right? So there are 2 men that would have z-scores that are greater than 2. Again, those would be, thinking about things that we've talked about before, those would be unusual values because we are outside of 2 standard deviations. In context, z-scores help us to compare different observations in one group with those in another, even if those groups are measured in different units or under different conditions. So that's the nice thing about our standard units, is it gives us a standard way to compare different things to one another. And then what we see down at the bottom here is a formula for calculating our z-score that we're going to be using for the rest of the problems pretty much in this section. So to find the z-score, we find the difference of the observed value in the mean divided by the standard deviation. So x is our observed value. We're using population notation here. So we see mu for our mean divided by sigma for our standard deviation. Or if we're thinking about samples, our z-score formula we could write as x minus x bar divided by s. I do put the top part in parentheses when I write out the formula, just to remind us that if we're plugging this into the calculator all at once, we want to make sure we put our numerator in parentheses, or if we do it as 2 steps, do that part first, do the subtraction, and then do the division. So we want to make sure that we're getting accurate z-scores using our correct order of operations. So whether you physically write the parentheses in there or just remember to do that part first, that's kind of up to you as you're doing your calculations on your own.